This is another question taken from the numericals from chapter light. This is the distance between a concave mirror and the screen is 5 meters. So we know the distance of a mirror and that of the screen. You should know that the screen is always placed on the in front of the mirror, because in case of a real image, the image is always formed on the screen. So one thing we get to know that the screen is distance from the mirror and the screen distance is given as 5 meters. So that means we know V here, and V has to be minus 5 centimeter. Further, it says that an object of height 1 centimeter is placed. So let's place an object that is in front of the mirror. The object is always placed in front of the mirror. So this is the object placed and its height is given. The height here is 1 centimeter is given. And the image is formed, right? On the screen, whenever the image is formed on the screen, it is always real and inverted. That means we are also given the height of the image here, and that is the image here is real and inverted. So the image will be formed on the screen and it will be real and inverted. So this is the image formed here. In this case, the image is formed on the screen and it is real and inverted. So let's write down all the information that we have symbolically. The informations that we have is one as 5 meter, screen distance, height of the object 1 centimeter, and the height of the image as 5 centimeter. So the image distance will be is indicated by V. So we'll be writing V is equal to minus 5 meter. Then we also know here the height of the object. Object is taken as 1 centimeter, which is given here 1 meter, I suppose. Yeah, that's 1 meter on centimeter only. And we know the height of the image. Height of the image is indicated by h dash, which is equal to minus 5 centimeter. Now let's understand once again why I have taken the height of the image as minus 5 centimeter. As you know that the image in this case so formed is a real and inverted, and the real inverted image is indicated by a negative sign. Now, what else we have to find out? In first part, we have to get the focal length, right? As you know, in order to get the focal length, we'll be applying this mirror formula. But in order to get F, we must know U as well as V. We know V here, we don't know U. That means in the first part, we will get the value of U. So to get the value of U, we'll be using this relation between the H dash and V and U. Now replacing these values with their replacing the symbols with their values. Let's say what is h dash here. I can replace this h dash as 5 minus 5. In fact, h, which is the height of the object, positive 1, and this minus is for the formula, and there is another minus will come as minus 5 meter. We don't write unit here, and u is what we are going to calculate first. So in order to get u, what you'll get here, this is minus 5 over 1 is equal to positive 5 over u. So by cross multiplication, we will getting u as 1. And here 1 should be in meter because this is the distance of the object and the distance of the image is given in meter. So it will be in meter. Now, once we get the value of u, now we are going to apply the mirror formula, this one, to get the focal length. And how we are going to do is, this is 1 over f is equal to 1 over u. U is minus 1, minus above, below 1, plus this is 1 over v here. 1 over v should be replaced with its value, and the value of v is this. So it will be minus above and 5 below. Now, with further working, you will get this as LCM as 5. This will be minus 5 times plus minus is minus. It will give you minus 1. With cross multiplication, you will get this as minus 5 over 6. That should be the focal length. And on calculating this, you'll be dividing this value you'll get 0 point minus 0.83, and that should be meter. So we got this size of focal length. That is the first part. We had to get the focal length, and we got the focal length as minus 0.83 meter. Once we calculated this, then we have to find the radius of curvature. You should know that the radius of curvature is twice the focal length. So we can say that radius of curvature will be twice of this value, that is minus 5/6 from here. So on this will give you minus 10, or say on reducing, we can say this is minus 5 by, that is minus 5/3, will give you 1 point, minus will remain as it is, minus 1.66 centimeter. If it repeats, we write 6.7 meter, not centimeter. And the position of the object, as you can see, position of the object is U, and we have already calculated. So object is placed here at a distance of 1 meter in front of the mirror. So now the final answer will be focal length, which is minus 0.83 meter. Then the radius of curvature, which is minus 1.16. And then the object distance indicated by U, object is placed at a distance of 1 meter in front of the mirror.